Welcome you all. My lecture is how to use the Vernier height gauge and its parameters. So this is the Vernier height gauge. The main use of the Vernier height gauge is precisely measure the vertical height of the components. Let me go for the parts. Let me go for the parts of Vernier height gauge. So this is the Vernier height gauge. Let me go for the parts. So this one is a base, and this one is a jaw, and this one is a main scale. We have a 30 centimeter. If you want to convert in mm, 300 mm. And this is a 1 scale. It will be having a 10 notation was given there. So each notation will be considered as 5 divisions. Totally 50 divisions in 1 scale. And this is a locking screw. And this is a clamp. And this is a slide. And this is a lens. We want to verify that measuring values. And this one is a stainless clamp. So let me go for that measurement of Vernier height gauge. So this is a Vernier height gauge. It consists of 2 scale. This one is a main scale and this one is a 1 scale. So I want to adjust the screw between above and below. So this is a sample component of an workpiece. So I want to measure the height of the sample components. Okay, I want to keep the jaw towards the workpiece is in the right corner. I want to keep on it. So first I want to check the main scale reading. In this scale we have in centimeter. Totally we have a 30 centimeter is there. I want to convert it as finally in mm. So therefore there will be a 0 coincidence is there. I want to check it. Here 3.2 centimeter is there. I want to convert it as mm means 32 mm. That is the main scale reading. And finally I want to take a coincidence of 1 scale. The 1 scale coincidence is, so totally here 1, 2, 3, 4. Totally we have a 50 division is there. The 20th division is going to be coincide with 1 scale. So the coincidence of 1 scale is 20 divisions. So already we got a setup of reading in our Vernier package. So the main scale reading will be coming for 3.2 centimeter. We want to convert it as an mm means 32 mm. Simultaneously we done a Vernier scale coincidence. It will be coming for 4 rotations. We want to convert it as a division means into 5. So totally 20 divisions it will be coming. VSC. So after that, the same coincidence value we want to convert it into least count. We want to multiply with the least count. So therefore, VSR is equal to, so 20 Vernier scale coincidence into least count 0.02. You want to multiply with these 2 means 20 into 0.02. So 0.40 the value will be coming 0.40. So finally the measure reading is equal to main scale reading plus Vernier scale reading. Measure reading is equal to the main scale 32 and Vernier scale reading is 0.40. So totally 32.40. So simultaneously we want to take another setup of reading. That's the second one. The same will be measured for the other right corner of the height of the components. And also will be the same 32 mm. The divisions, the total division is 44 in Vernier scale coincidence. The same thing, the 1 scale reading is equal to, so 44 into 0.802. You want to multiply with the least count. So therefore 44 into 0.02 is equal to 0.88. So finally the measured reading is equal to MSR plus VSR. So 32 plus 0.88 is equal to 32.88. So finally we want to make an average for measurement 1 and 2. The first value is 32.40. The second value is 32.88. So the total average is 32.6. So this is a best average measurement value of this Vernier height gauge.